Welcome back to our grade 11 maths lessons. I am Miss Aunu, one of your maths teachers. Okay, now last lesson, we looked at multiplication of vectors. And we looked at one application of vectors, which was force. Today we're going to look at another of those applications, and we are going to see velocity vectors. Okay? Velocity vectors. Now you can see on the board already we have a cyclist, okay? We have a cyclist. We're going to find his speed and his bearing. He's going on a trip, okay? He's taking a bike ride somewhere, all right? Now remember that on a vector, the magnitude or the length of the vector is his velocity or speed, okay? Now, the cyclist here, his velocity, okay, now remember velocity is a vector. So his velocity is given as 3I minus 4J meters per second, all right? So this cyclist is moving in a certain direction. We don't know his speed, but his velocity is given as 3I minus 4J meters per second, all right? So we know that I and J on a Cartesian plane, I is the distance of movement across on the x-axis, and J is the movement on the y-axis, okay? So we can actually show the cyclist journey on our Cartesian plane, okay? So the center of our Cartesian plane is his starting point. So this person, Joe, is here, all right? And he's moving 3I, a distance of 3I, okay? So that's on the x-axis, 1, 2, 3, all right? And minus 4J means that he's going downward, all right? And we have 1, 2, 3, 4 here, okay? So we need to draw a triangle that is going to show us, okay, the distance we are looking for. Sorry, the speed, okay? So the cyclist started here, and he's traveling in this direction all the way to this point here. So that is the vector we are looking for, all right? Remember again, this forms a right angle. Okay, so 3 across and 4 down. Okay, now, so Joe, his velocity is given as 3I minus 4J meters per second. And on the Cartesian plane, we can actually see the direction he is moving, all right? So the length of this vector is what we are looking for, his speed, okay? So in order to find the length, remember we've done this before, the magnitude of, let's say it's vector V, yeah? Okay, so the magnitude of V is found by taking the square root of which two sides already given here, this side and this side. Okay, so we're looking for this vector. Okay, so we're using Pythagoras. And we have 3 square plus 4 square. Okay, we know that 3 squared is 9 plus 4 squared is 16. So that's square root of 25. Okay, and square root of 25 is 5. Now this is an application of vectors, so it has a unit of measurement. This is speed, so that means it is 5 meters per second, okay? So we've found a speed that he is moving. That means for every second on the clock, he moves 5 meters, okay? So this cyclist he's quite fast, if you think about it, okay? Now, we want to also know the direction in which he is moving. So that direction, and again, we've learned about bearings already, is taken from the north, okay, down to the direction in which he is traveling, okay? We don't know the angle here. This is going to be theta, all right? But we do know that this measurement here, or the angle here, is 90 degrees. Okay, so in order to find theta, again, we are going to apply trigonometry. So if you look at our triangle, we have the opposite side and the adjacent side given. So that means we are using the tangent ratio. Okay, so let's see, we're going to find the bearing here. So we use tan theta equal to opposite of 4 and adjacent of 3. Okay, now theta is therefore equal to, and you've already learned again how to use your calculator to find the value of 4 over 3. Okay, so this should give you an angle of 53, okay, 53.130. And of course, there are other numbers here, so we'll just put these 3 dots down to indicate that we want to be as accurate as possible, okay? So the angle we get from using the tangent ratio is 53.130 degrees. That is this angle here. Now we're not done. The next step is to add 90. So we get 90 degrees, all right, plus 53.13 degrees. And our final answer will be 143.130 degrees, okay? Now we can round it off to the nearest degree, all right? That will be 143 degrees, all right? And in brackets, we need to indicate that nearest degree, okay? So, Joe, our cyclist, is traveling at a bearing of 143 degrees, and the speed in which he is moving is 5 meters per second. So his speed here is 5 meters per second. He's moving quite fast, and he is going in the direction of 143 degrees, okay? Now this brings us to the end of the lesson. I hope this example has actually shown you the way we apply vectors in real life, okay? So we've been learning about adding and subtracting, multiplying, and we've already used these skills here. We've already learned them. Now we are simply applying it to an everyday situation. So you see where we use vectors, okay? So this is the end of our Term 2 lessons, all right? And I will still be with you in Term 3. We're going to look at algebra. It's an extension of what you've already done in grade 10. So stay with me if you want to learn a little bit more on algebra. Thank you.